Hello, greetings to you all. I welcome you back to our next section under differential equation. Alright, I would like to introduce to you my reference book, that is revised edition of ordinary differential equations, a first course for tertiary institution, written by Asiedu Ado SK, that is Professor Asiedu Ado SK and Dr. Ali Muhammad. I would like you to get their books and reference on it for your further studies. There are a lot of questions embedded in it and all that. I would like you to get it and it will help you. Alright, thank you. So today, in our previous lesson, we learned about separable differential equations. Separable differential equations. We all realize how easy and simple going with such method is what? Is B. Alright, so okay, so that is it. That's it. Now we have looked at one method, and that is separable differential equation. And as I said, that's the easiest method. Alright, so we are coming to our second method. But please take note, before you tackle any differential equation question, you need to analyze the type of differential equation it is. Is that differential equation separable or not? Now, all that we have done so far is separable differential equation. So you are only used to only one method. Today, I would like to introduce another method to you, and that is homogeneous differential equations. Therefore, whenever a question is given to you, you need to analyze first the type of differential equation what it is. So, when we talk about homogeneous differential equations, what is it all about? A function of f in terms of x and y is said to be homogeneous of degree n in the variable x and y if for any lambda the following identity is what? True. Alright, so we have the function, and that's that. That means what we mean here is that you'll be given a function which is in terms of x and what? Y. And for you to verify whether it's a homogeneous equation or not, when you do a substitution or when you attach the x variable there with lambda and the y variable there with what? Lambda. Or when you multiply the x variable there with lambda and the y variable there with what? Lambda. And if only you'll be able to substitute the lambda, alright? If only you'll be able to substitute the lambda, then we say that differential equation is what? A homogeneous differential equation. And the power n here means that the power n here represents the degree of that what? Homogeneous what? Equation. So that is that. We are going to look at examples for us to know how we can go about this. So let's see. Verify whether the following functions are homogeneous or not, and indicate the degree of homogeneity. So let's go straight to our point and look at the first example. And in the first example, we have that to be cos xy over sy. Alright. So what we do is that firstly, we multiply the variable x by lambda and the variable y by what? Lambda. So let's do that first. Alright. So what we have done here, let's do the same thing for this side. So cos lambda times lambda y. All this over lambda s times lambda y. Alright. So here we are going to get cos lambda square sy over lambda square xy. Now, this is where, or this is what we are just talking about. We can see that here, this one we have inside here is an argument for the what? For the trigonometric function cos. And in such case, there is no way that you can factor an argument out. If only you can factor this argument out, then it can come and cancel this. But in this case, we can't factor this argument out. So we can now conclude that this differential equation is not homogeneous because we can't factor lambda out. We can't factor what? Lambda out. So in such case, this failed to be a differential equation. So not going to be a differential equation, but rather homogeneous differential equation. So not homogeneous. Alright. Let's go and look at our second example. Okay, so in our second example, that is the B, we have a function f, y, square root of x squared plus y squared over y. Alright, so looking at this, the first thing to do is to multiply the x by lambda, y by lambda. So when you get inside the function, now watch. This one is already there. Alright, so our concept is to multiply lambda by x. So we have x here, we multiply by lambda, okay? Then we have y here, we multiply by lambda. In the same way, this we multiply by lambda. So looking at this, we are going to get something like lambda squared x squared plus lambda squared y squared. All this over lambda y. That clear? Alright. So here you can see that we can factor lambda squared here. And here will be x squared plus y squared. All this over lambda y. Now, looking at what we have here, let me repeat again because it's very, very important. X squared plus lambda squared, all this over lambda y. Now, we can see that with this, you can rewrite it as lambda squared times square root of x squared plus y squared. All this over lambda y. And with this will cancel it. So lambda square root of x squared plus y squared over lambda y. Beautiful, beautiful, beautiful. So looking at what we have here, we can see that this is going to cancel this, alright? And we are going to get the function back exactly. The function backward exactly. And in such case, then we say that this differential equation is homogeneous. Is what? Homogeneous, because we have been able to factor out what? The lambda. So that is what? A homogeneous differential equation. Alright, let's look at our second example, our third example. And if you want to know the degree of this is of degree what? 1. Alright. C. We multiply this by lambda, then we equate to sine lambda y over cos sy. So we have sine sy. Let's do it. Sine cos, alright, and the argument is just sy. So we multiply sy by lambda and these two by the y2 by lambda. We multiply the x here by lambda, this one 2 by what? Y. So here we are going to get sine lambda square sy over cos lambda squared sy. Beautiful. And looking at this is of degree 2. But here, there is no way that we can say that then this lambda will cancel this lambda, this one out, so that we get the function back. And that makes it what? A homogeneous what? Equation. So with this, you can never use an argument to cancel an argument. So in such case, this is not homogeneous. It is not homogeneous. So you can see that anytime we have a trigonometric function, it's called a trigonometric function in such questions are now giving us not what homogeneous. So can we now say that such questions that we have the trigonometric functions in, they are all not homogeneous? Well, we can't generalize for now. Let's continue and see. But the concept is that it can never cancel out. Alright. D. In the D2, we have f lambda s lambda y to be equal to, here we have, okay, don't worry, let me repeat everything. Since that place is too wide. So the function that we have there is sy e raised to the power x squared over y squared plus y squared. So the function of x, y. Alright, so that's what we have. That's exactly what we have. So we now attach or multiply lambda by x, lambda by y to be equal to, here, attach lambda by x, lambda by y, e raised to the power lambda by s all squared over lambda by y all squared. Please, I hope you can see that. Just attach lambda by x and lambda by y. So the square will affect it. In the same way here, lambda by y squared. Good. Okay, we continue. So this you get lambda squared sy. And here we get lambda squared x squared over lambda squared y squared. Hope you can see that. Trust you. And lambda squared y squared. Very good. Wow. So here you can see see that this will clear up this. And we are going to get lambda squared sy e raised to the power x squared over y squared plus lambda squared y squared. But here we can factor lambda squared out, okay? And when we factor lambda squared out, we are going to get sy e raised to the power x squared over y squared plus y squared. Very good. So now we have been able to factor lambda squared out. So this is of degree 1, 2. We are able to factor lambda squared out, and for that matter, we say that this differential equation is homogeneous. This differential equation is homogeneous, and the reason is simply that we have been able to factor lambda squared out. All right, let's go for the. Oh, I would like you to try this one on your own. I would like you to try this one on your own. Ln x plus y over x minus y. Alright, so lambda x, lambda y is equal to ln lambda x plus lambda y over lambda x minus lambda y. So here we see that ln lambda x plus y over lambda x minus y. Alright, and you can see, in fact, this one too is an argument. What you have here is an argument. But yes, still we can use this to cancel this, alright, because it's all an argument. So you can use an argument to cancel an argument, but not with a different function. Alright. For instance, when we're having sine over the cos. So here we get ln. Alright, so here we get ln x plus y over x minus y. So we get it back. So this is purely a homogeneous differential equation. Wow! 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 So that is how we verify whether a certain function is or equation is a homogeneous or not what? A homogeneous. So please, now we are introducing you to a second technique to solve differential equation question. Make sure you analyze it well to know the type of differential equation it is before you go on to solve such question. So let's see. We are now going to find out then how do we solve such differential equation. So see you in this video. I'll be back.